summarize the whole idea to calculate the area by revolving the curve about one axis. So we can just follow the differential form. Sorry. Okay. The differential form for calculating the area of revolution based on some axis of revolution. So you can see that the surface, the area of surface, should be defined as integral from A to B 2 pi y ds. So you can easily memorize the formula when the revolution is about x-axis. It's about x-axis. Then you can also notice why here I just write down as ds instead of dx or dy. Later I will show you why. Okay, this is for when the revolution is about x-axis. Similarly, if the revolution is from about y-axis, the answer will be like this one, but here is still ds. So if this case is for the revolution is about y-axis. But you can see why here. You can notice why here is ds. Please just, you can try to use this one. Did you still remember that we just point out this part? ds could be regarded as dx squared plus dy squared over dx squared, then times dx. I'm not sure if you still remember this. Maybe I can just find a file and then let me show you where. Okay, here. Maybe just like maybe last time, right? Oh, now this one. Okay, here. Did you remember that? I also point out this concept that ds is equal to square root of dx squared plus dy squared. Right? So with this, you can see when I try to get this one, when I try to get this one, I can replace ds as this one over dx squared here times dx. So similarly, you also can replace this one dx here also as square root of dx squared plus dy squared over dy squared, then times dy here, right? So, and then we can continue to convert it as it will become 1 plus dy over dx squared times dx. So similarly here, we also can have 1 plus dy, dx over dy squared times dx. So you can see once you just convert it as this one, then the whole formula will become like s is equal to square root of from a to b 2 pi still y, right? But with this we will become 1 plus dy over ds squared times dx. Here is also, you can just convert this into this one, c to d. Square integral from c to d 2 pi x times square root of 1 plus dx over dy square dy. So that's why actually if we can convert this from here to here, that means we also can convert this one back to here. So you can also have a comparison as last time I just showed you. Did you still remember? I just asked you if you want to calculate the surface area for revolution about x-axis. I just asked you to memorize that the surface should be integral from a to b 2 pi. Remember, if x-axis here should be y, then times square root of 1 plus dy over dx squared, integral with respect to x, right? So likely if it's from y-axis, the answer would be this one. So last time I just asked you to memorize these two formulas, right? But right now I can continuously simplify the form from this one or this one to be one on the basis of ds. So you can see, I just show you this one, right? But of course you can follow this one and also this one, then go back to this one. If the revolution is about y-axis, you also can have this one, then through this relationship, then go back to this one. So you can just have a look at these two forms. If we just follow the differential form, we even can simplify the formula you memorized earlier, that originally it should be this one. You can convert it into this one. Originally you have this one, then you can just memorize this one. So you can have a comparison. If we just keep these two ones in your mind, it will become simpler. Why? Because you can see if the revolution is about x-axis, all you need to memorize is integral from a to b 2 pi y if x-axis, then ds. If the revolution is about y-axis, it will be integral from c to d 2 pi x, okay, then ds. So you can see here ds, here is ds. So you don't need to memorize too much. Only what you need to memorize is if the revolution is about x-axis, remember here should be y. If the revolution is about y-axis, here should be x. Okay? So with this, we even can reduce the form for these two ones. No matter this one or this one. Finally, you just need to memorize s should be integral 2 pi times radius times band. Maybe I need to use radius and then, okay, use yellow one. Band width. So places have mapping. I just make it smaller so you can have a whole view that you can see. So what you need to memorize, integral 2 pi integral 2 pi, right? Then radius. So radius will be, if the revolution is about x-axis, the radius will be y. If the revolution is about y-axis, the radius will be x. Then ds here is the bandwidth, the arc length, the arc length. The bandwidth should be here. The bandwidth should be, I just point out here. ds is means the length following the curve. Okay, so finally, if we want to memorize it, you can just keep this in your mind instead of this one, these two ones. Instead of these two ones, these two ones. OK， 我这边很快 summarize 一下啊，就是说这部分其实只给大家一个观念，其实你不一定要很认真去把它记下来，但是它给你一个很重要的观念，就是我们在做旋转表面积的时候呢，它跟哪一个轴旋转是有相当大的关系的。这个大家都知道，不管旋转表面积、旋转体积，其实都是一样的，跟哪一个轴转出来的效果就不一样。这我想大家都可以理解。那我们这边算的是旋转表面积。那这礼拜一的时候教给大家是这种样态，事实上应该也要记这个样态的。不过就是说这两个样态可不可以把它 reduce 成单一个，这是我这边介绍的目的。所以之前我们在背的时候是说，如果你今天是对这个 x 轴旋转，记得你的公式是2派 y， 其实这边虽然写 y， 其实因为你会被赋予 y 等于 blah 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 x， 所以虽然这边写 y， 事实上到最后你会把 y 等于 blah 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 x 带进来，所以这边会整个变成什么什么 x， 然后这边呢会变成根号1加上 y 对 x 微分出来也是 blah 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 x， 最后自然对 x 积分。如果今天旋转的轴是 y 轴，刚好恰好相反，这个地方变成 x， 这边变成 dx over dy， 然后这边是 dy， 为什么？因为 x 一定会等于什么什么什么 y， 这一段呢延续出来也会1加上什么什么 y， 最后你是 dy。所以其实最原生的是你要去记这两个公式，当你的旋转轴是 x 轴或者 y 轴是不一样的。那我们这边要跟大家介绍的是说，那我可不可以把这两个公式再进阶的把它 merge 起来，变成一个公式就好了？就不管你今天是就是说对旋转，针对 x 轴旋转或对 y 轴旋转的时候，我可不可以把它精简，再把它精简下来？那它的做法是这样。事实上呢，刚刚那个公式啊，上一页介绍的公式是这里，对不对？如果对 x 轴对 x 轴旋转的时候是这个公式，对 y 轴旋转应该是这个公式。可是呢，经由我们对 ds 的了解 ，ds 本身是根号的 dx 平方加上 dy 的平方，还记得我说那个就是一个直角三角形的斜边的概念，对不对？你把它换掉之后啊，经由 differential form 的概念，你可以把它精简成变成这个样子。为什么？中间这一串变成 ds。右边这个呢，虽然是对着 y 轴旋转呢，这边是2派 x， 但是你这边也可以把它变成 ds， 原因都是由 ds 可以转成这个样态，也可以转成这个样态而来的。所以最后呢，你的公式变成什么？记这两个，对不对？好，那这两个有没有再办法进一步精简？本来是红色的，已经够精简了，对不对？我事实上可以把它精简到变橘色的。橘色是什么？积分2派，大家都有2派，对不对？这边我们先看黄色的部分 ，ds 就是那 bandwidth 上礼拜有提，这礼拜也有讲到 bandwidth， 我们做的是这个有没有？用这个的宽度当它的 band 的这个宽度，我们叫做 ds， 所以我们用 delta s， 粗一点叫 delta s， 细一点叫 ds。 所以这个就是 bandwidth 哦。然后呢，你的对x 旋转的时候的 y 代表是什么意思？就是这个曲线在某个定点的时候呢，它跟这个 x 轴的距离，哦，通常是 y 等于 x。所以同样的，如果是对于 y 轴旋转的这个 x 这边代表是什么意思？这个是这个曲线在某一点 y 的时候，它跟这个旋转轴 y 等于 y 轴上面的距离。所以最后这两个公式更进阶，你就可以只要记这一件事情。好，那当然这个是一个理论的就是让大家容易去记的一个方式，但是最终事实上你在算的时候，当然还是要回归到这些公式啊。但是我们经过这几个步骤啊，其实整个公式可以精简到变成这个样子。好，这就是这部分要交代给大家的哈。So normally, if you just find our textbook, you can see I will draw the picture for you that okay, if the left hand side is like this, x, and this is y is equal to f of x, right? And then the revolution is x-axis. Then through the small ds here, you can just use the y as its height. This means y. Then you just revolution like this way. So you can see it will be 2 pi. 2 pi means the whole circle times radius. Radius means here times bandwidth ds. So similarly, if this is just like this way, and the curve is something like this one. This is x is equal to blah blah blah. That means g of y. Then the revolution, the x-axis revolution is here. Then I just resolve it. You also use the ds as the bandwidth. Then we also use this one as x as its radius. Then we can get the whole surface. So you can just have a comparison for here and also here. And finally, you can see this one can unify the whole formula. You can just use this one to memorize the formula for both. So that means what you need to keep in your mind is just this one. But the reality is when you just want to calculate the surface, you still need to go back to these two ones. But with this, we can just unify the whole formulas. Okay, so in our textbook, we also can reduce its integral 2 pi times rho times ds. Rho here means the radius. Rho here is the radius. ds here is the bandwidth. Okay, so you can see compared to these two ones, finally you can just use this one for both. So what you need to measure is what the radius is. That will be rho. What the bandwidth is, that will be ds. Okay? Then before go to the end of this chapter, I'd like to use another example to show you that how to apply that. Okay, for example, if I give you the curve is just following y squared is equal to 4x. Please just find the area. of the surface, which will generated by revolving y about x axis from s is 0 to x is equal to 3. Okay, so once you were giving the question just like this, then you need to find out some key factors. The first one will be the curve. The curve will be here, right? The second one is what is the, so through this one, you should try to find the radius. And the second one is the revolution. The revolution is x-axis. And also you need to notice that where from point A to point B. So this is the start point, and this is the end point. So you need to just use these three clues to form your integration. So based on this, we already know that the surface should be integral a to b 2 pi. Okay, 2 pi. Can you just answer me? Here should be x or y. 2 pi. Here, y. Why? Because we just want to revolve in y about x-axis. Remember, if the axis of revolution is x-axis, here should be y. Then times square root 1 plus dy over dx square, then dx. Right? So through this, that will be y. Okay. So this is the formula, right? So if y here, and then we also need to know this one, right? We also need to know dy over dx. But you just have y squared is equal to 4x, right? If you want to get how to get dy over dx, how to get? We can use implicit differentiation. Don't forget the rule of implicit differentiation. You can see I did not give you the explicit expression for y is equal to blah 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 x, right? I just give you the relationship between x and y. So with y squared is equal to 4x, can you just find the corresponding dy over dx? Yes, you can do that. We can just use implicit differentiation. So if so, we can just, how to do that? If we already have y squared is equal to 4x, we can just differentiate at both sides, right? Then we can have 2y times dy over dx is equal to 4, right? Then 4, so then we can have dy over dx is equal to 2 over y. So right now we will have 2 over y here. Then we continue to try to get this one. That will be 1 plus 2 over y squared. So it will be y squared over y squared over plus 4 over y squared. Right? We already have dy over dx here. But our target is we need to have 1 plus dy over dx squared. We'll continue to get this one. Then finally, just put it into the whole formula integral from the question just this x should be from 0 to 3, right? From 0 to 3, then 2 pi y times square root of y squared plus 4 over y squared. Because we can just simply use this part to replace 1 plus dy over dx squared. So y here can be cancelled together. Then we can have integral from 0 to 3. Then here can be cancelled, right? Then y squared can be replaced with 4x. Why? Because y squared is equal to 4x. So that will be 2 pi square root of 4x plus 4 dx. So that it will be 4 pi times square integral from 0 to 3 x plus 1 to the power 1/2, and the final result will be 56 over 3 pi.
老师，那y平方那取绝对对值是那开杠是要先取绝对值啊 ？y 平方是。
哦，哪一个？
就是那下面那个 y 平方，第二个要取绝对值。
取对值没关系，那因为它是在正的这边。
正的就是直接
就不用了，对。Oh, I forgot to put dx here. Sorry.
这个都是正的。对。因为外面等于这个值都会大于等于0。
对对。你可以看从 y 平方那部分可以看出哈。那这个重点是在哪里？是说这个技巧是在哪里哈？大家要注意到的是这个技巧，要用隐函数微分才可以得到这个 dy over dx。这个是这个的技巧。
那如果是直接的 y 等于正负高 c 可是可以。
正负。哦，没有，这个题目它给你的曲线。这个呢 ，y 平方等于 4x 是什么曲线？你知道吗？是一个抛物线。Maybe I can just show you. Maybe just like this one. S y, and then.
如果是那直接 y 等于正负高 c 可是也可以算出来。
什么意思？这个是 y 平方等于 4x 曲线是长什么样？大家知道吗？它是开口向哪一边？右，对不对？是这样子。这是 y 平方等于 4x， 然后0到3在哪里？0 s 等于0到3嘛？不对，对，0到3在这里，对不对？这 s 等于3，那它现在是用这个，应该是用上半段，其实。这个应该不会有问题，就是你不管你是用这个 revolution 还是用这个来当 revolution，
他们结果都一样，
会一样，因为它都是对这个 y 轴 旋转轴是这个。
那如果是 y 等于正负杠
Sorry。不用管它。哎，那你说。
就是 y 等于正负杠 c x 也可以算，然后把 y 带进杠 c x， 然后对，这样也可以。
你再讲一次。
就如果 y 直接呢
y 直接。
用
哦，你说看带正负，我是怕你逗出来积分会积不出来。你看哦，你还是要解决这个问题。你可以直接带进来，但是你到时候消跳到你看，它会消到跟我们一样。你知道我意思吗？你把它消掉之后，这边刚好它产生出来会有一个这个 y 的效果，你抵消掉，你就不用再去带那个 x 了。照理说了哈，照理说你这边 y 要带成 blah 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 x， 然后这个算出来应该会 blah blah x。但这个例子是你出来的 y 跟这个 y 刚好抵消掉，你就不要再去处理那个 x， 不要处理那个 y 等于 blah 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 x 了。那你的做法当然是应该也是可以的哈，就是你去把它的正负4x， 就是用这个上面下面对不对去做旋转嘛哈，所以这个应该是可以。但是这里有一个好处是，我旋转过来的时候，这个地方我换过来的时候，这个部分跟这部分可以抵消掉，你就可以省掉这些计算。哦 ，OK。Oh, so I'm afraid this part is the last portion for session 4. So let me just quickly summarize this chapter. In this chapter, we are trying to apply integral to get the volume by revolving some curve through some axis. So for the section 1, we just use a cross section to get the integral. So in section 1, the first thing you need to find is the typical the area for the typical cross section. For the section 2, we still focus on how to get the volume by revolving the curve. But this time, we also learn two types. One is the disk measure. The other one is the Washoe measure. Disk measure, Washoe measure. Okay. Then finally, we just learn shear measure. Did you remember I just give you a tip? How to distinguish the you should apply disk measure, Washoe measure, or shear measure. The idea is please just the first thing for you is just draw the region first. Then you try to draw intersection through the area. If the intersection is parallel to the axis of revolution, you will follow shear measure. If the cross section is perpendicular to the axis of revolution, you will use disk or Washoe measure. Did you remember I just told you? So sometimes the question can be solved by both ways, but you need to measure which one is suitable. It should be better for you, because last time I also show you some example. Maybe I also can give the example to you that last time I show you that here I show you that not this one. Here. Okay, next time I show you a typical example. For example, this is a cross section. This is a cross region, right? So if you just draw the cross section here, the cross section is parallel to the axis of revolution, then you will follow shear method. The shear method will be following this formula: 2 pi shear radius, shear height dx. But if your cross section like this one, if your cross section is just like this way, you can see the cross section is perpendicular to the axis of revolution. You will use Washoe method. Actually, Washoe method is equivalent to using the Dix method twice. Did you remember that? Right? So actually, Washoe method is can be regarded as just a typical is an exception for the Dix method. So, but you can see both way can help you to find the volume. But you can also notice that if you just use the shear method, the integration form is much easier. But if you just adopt Washoe method, you need to divide the curve into two parts. One is the outer part, the other one is the inner part. Then you need to use the Dix method twice. This is the outer part, this is the inner part. Then you still can get the same answer. But you can see this one is much complicated compared to this one. So it's really hard to say which one is better. But if your judge is correct, they can save some effort for you to calculate the volume. Okay, so this one, I should say this part is very important because when you just want to adapt the correct method to solve the question, the better to draw the region first and figure out which one is your axis of a revolution. Then try to find the best way for you. Of course, as I told you, that either this way or this way, if your calculation is correct, you still can get the correct answer finally. However, you can just make a simple comparison here. You need to spend more effort in calculating the final results compared to this one. Okay, this part is for applying the integral to solve how to get the volume for when you just revolve some curve about one axis of a revolution. Then I also that will be, we can just in section 3 we just try to use this to calculate the arc length. The arc length. So the arc length, the formula for the arc length is this one. And then finally, we also learn how to get the area of surface of revolution. So the formula is also like this one. So you can see this is very similar to the arc length. However, 2 pi fs here is different from the previous one. Here is just used to calculating the surface, so you can see area. But here is for arc length。这两个是不一样的，一个是长度单位，一个是面积单位。那第二节讲的是体积单位，所以在这个章节里面基本上虽然只有4节而已但它已经涵盖了用积分来算长度，用积分来算面积，用积分来算体积。所以我们举的几个有限的例子里面，最典型就举了一个圆球，透过圆去旋转，算出它圆的绕出来的体积，就是球体积。跟用圆去绕出来，去得到圆那个球的表面积。 这个章节是非常重要，这4个节哈。那第5跟第6我们就跳过去了哈，就因为它是跟物理的功比较有关系，我们就跳过去。但第6章的这个部分，你们光看就知道它一定会考的啦，哦，一定会考的，就期末考的时候一定会考的。那就是要不大家把这个到底在旋转在用哪个轴的时候要搞清楚。那最重要的就是先把这个区域先略的勾勒出来，像我这样每次解的时候，大概就会稍微把这个区间 B 区间的部分画给大家看一下哈，哦，会稍微画一下给大家看一下，哦 ，OK， 那这是第6章的部分。那等一下我们休息完以后，我们就从第7章开始。那我们期末考预计了哈，考到7之3，7之4会讲，但7之4就不考，但会考到7之3，好。但第7章有点重哈，所以其实我们也要加快脚步哈。那我们先休息一下哈。So for chapter 7, we will talk about the transcendental functions. So, in Chinese, transcendental function normally we just translate as 超越函数。Maybe we already know the like algebraic function. Algebraic function. So actually, algebraic function coming from like polynomial function through 4 operations like addition, subtraction, and multiplication, division, and taking root, right? I believe you still remember that, right? For our first class, we already know that. But today, we will talk about the transcendental functions. So what is transcendental function? Actually, you have already learned some transcendental functions. Just like sine function, sine, cosine, okay? But in this chapter, we will learn about hyperbolic sine, hyperbolic cosine. So you can see I just add h here. Here means h means hyperbolic. Hyperbolic. Sorry. Too ugly. Hyperbolic function. I should say hyperbolic function is also a set of functions. There are 6 hyperbolic functions. These 6 hyperbolic functions are very similar to the trigonometric functions. We know we have 6 functions for trigonometric functions, right? But for hyperbolic, the family also includes 6 functions: hyperbolic sine, hyperbolic cosine, hyperbolic tangent, hyperbolic secant, and hyperbolic cosecant. So this is a hyperbolic function, but for this part, maybe we will just reach this part next semester, and we will also learn about logarithm function, like this one. But you may say you already learned this before, right? And we will also learn about the exponential function. E here is a constant. This is a constant. So we will also learn this later. All of them are hyperbolic function. All of them are hyperbolic function. So compared to polynomial function, for example, we already learned a lot, like this one or like this one, right? This is a typical through polynomial function, we can get the algebraic function. But this time we will pay more focus on transcendental functions. Okay, before that, I want to introduce the first concept to you. This is the session 1. We will talk about the inverse function and its derivatives. So before we just introduce the inverse function to you, we need to know what is one-to-one function. So if we say function f of x is a one-to-one on a domain, D, if f prime s is not equal to f of x2, whenever s1 is not equal to f of x2, s1 is not equal to s2, and x1, x2 belongs to D. So you can see that even though actually the formal definition is just like this one, if f of s1 is not equal to f of s2, whenever s1 is not equal to f of s2. But it's the formal definition. But we more frequently use the following definition is, that means if you have this, that means when s1 is not equal to s2, then we make sure f of x1 is not equal to f of x2. But we also can convert it into, if f of x1 is equal to f of x2, then we can conclude f1 must equal to f of x2. x1 is equal to x2. So this is just kind of P imply Q. That means equal to not Q imply not P. So you can regard here is P, then here is Q. So normally we will use this one. Normally we will use this one. If f of x1 is equal to f of x2, we must conclude s1 is equal to x2. Okay? So that we can just give you some example. If f of s is equal to s squared for s is larger than or equal to 0, is it a one-to-one function? Yes, it's a one-to-one function. Why? Let me show you. If without this criterion, actually, is this a one-to-one function? Let me show you. If f of s is s squared, the function we just do like this one. The so-called one-to-one function, that means if, for example, this is not a one-to-one function. Why? Because you can see if s is equal to -1 or s is equal to 1, both of them have the same function value, right? Here should be 1, here also should be 1. So it is not one-to-one function. Why? Because as the definition here just mentioned that if f of s1 is equal to f of s2, we must have s1 is equal to f of s1 must be equal to x2. But you can see function value, if function value is 1, we have 2 points. They are different, but they have the same function value. So this is not one-to-one. But if I just add, this is for its natural domain, it will not one-to-one. But compared to this one, if I just force the function just focus on this part, that means f of x is equal to s squared, but x is restricted to a positive number of 0. Then you can see the curve, we just have the right half without left half. So you can see at this moment it's a one-to-one. Why? Let me just take s is equal to 1 as an example. The function value is 1. But if I ask you, with this condition, only one s is equal to 1 can have the function value as 1. But if you just take this example, I don't set any restriction for the domain. So that means the domain for x should be from negative infinity to positive infinity. So if I ask you whose function value could be 1, then the answer will be negative 1 or 1 can satisfy. But in this case, only s is equal to 1 can satisfy this condition. So you can see this is a one-to-one. But this one is not one-to-one because we have this. But they don't have. Okay? So this is a one-to-one function. So how can we just make sure if it is a one-to-one function? You can just using horizontal line test. How to use horizontal test? You just use the horizontal line. You use horizontal line. You can see when you just use the horizontal line to cross the curve. You can see here we have 2 intersections. So this is not one-to-one. But if you just use a horizontal line, pass through the curve, there is just 1 intersection. So it will be one-to-one. So did you still remember we used vertical line to check if this is a function? Did you remember? Vertical line to check if this is a function. Right? But we just use a horizontal line to check if it is a one-to-one function. 还记得吗？我们上课第1堂课就讲过，用什么垂直线来检测是不是函数，有没有？我们说函数必须怎么样？函数必须只能1对1，对不对？或者是多对1都没关系，多个1个以上都多嘛，多个对到同一个，所以这是个函数哦，对不对？因为你这样下来之后，你就会组个交点。但函数不可以怎么样？1对符，就是你在domain里面不能对到没有点，或者是1对多，像圆就不是，对不对？这我们在第几节课讲过，没印象。那时候用垂直线去检测是不是函数。那如果你要检测它是不是1对1函数，很简单，曲线如果画出来之后呢，你就画水平线，去看它会有几个交点。如果水平画过去，像这个例子，它会有2个交点，这个就是1对1。为什么？因为它违反了原则。原则是什么？如果2个函数的某2个点 拿下来一点哈。某两个函数的点呢是相等的，它一定这两个点一定是同一个点。这句话白话来说就是这样子。两个函数的值相等的话，它的点一定是同一个点。所以这个就是了，对不对？这个就不是嘛。两个函数值相等，但是呢，这两个点可以是不同的点，这不是一对一。这个因为我约制在 s 大于等于0，所以只有右半边，所以不管你水平线怎么画，我永远呢跟这个曲线只有一个交点。也就是说，你给我函数值的某一个点呢，其实只有一个点会对到，依据这个约制。Okay, so this is a one-to-one function. You can just use horizontal line to text. So with the concept about one-to-one, then we can furthermore define what is the inverse function. So what is the inverse function? If f of s is one-to-one, remember, it must be one-to-one on a domain D with a range R. The inverse function, normally we just use f inverse. Actually, this is different from f inverse. It should be like this one. It's different. This is for inverse. Okay, so this is inverse function is defined. This is also a function is defined by f inverse. A will be B if f of B is equal to A. So this is very important. If you just use B as an input for this f function, you can get the function value returned by A. Then for inverse function, you use A as an input for this inverse function, you can get B. So for example here, for this as an example, or maybe this is a good example, maybe I just use this example. If I still focus on f of s is equal to s squared, s must be positive or 0. So you can see if 2, we can get the function value is 4, right? So in this case, f of 2, we can get 4. It's a one-to-one function. So if f inverse, we use 4 as an input, then we can get 2. So you can just see like this way. For f function, x will be the input. Then through this function, I can get 4. But for the inverse function, you will use the 4 as an input. Then you go back to get function value 2. You know, it's just an inverse process. Okay, so you can see that the domain of f inverse will become R, and its range is D. So did you just notice for f function, its domain is D, its range is R. But if it can have inverse function, you can see its domain will become R, and its range will become D. Right? Let me just emphasize it again. For f of x function, if its domain is D, its range is R, then once we get the inverse function for this f function, then the inverse of f for the inverse of f, its domain will become R, but its range will become D. So the role has been exchanged. OK， 值域跟定义域呢，在原来函数跟它反函数之间，它的角色刚好互换，角色就互换了。本来在值域的人呢，就变成反函数的，本来在定义域，在函数原生函数的定义域的人，就变成反函数的值域。在原来函数的值域的人呢，就变成反函数的定义域，这样了解吗？角色互换。So with this, we can also see that if AB is on y is equal to f of x, then we can imply that BA is on y is equal to f inverse of x. Right? A as the input, we can get B. But for inverse, B will be the input, then we can get that back. So this is an inverse function. So I also can draw you actually these two functions. If y is equal to f of x, the function, if we just do like this one, AB, right? But for inverse, inverse, we maybe let's just like this. This will be BA, then this is y is equal. It's the inverse function, the inverse of f of x. So we can see if we have point AB on y is equal to f of x, we must have a B, comma A is on y is equal to the inverse of f. So actually, these two functions will be symmetric on y is equal to x. 正反函数你只要画出它的图，它一定会跟 y 等于 x 这条轴呢做镜射的，很容易理解嘛，因为有 AB 在在原来的函数上面呢，就会有 BA 在它的反函数上面，So there are two nodes. Node 1 is if we just use f inverse, composite f that will be x for all x belongs to D. You can see this is a composite function, right? So the first function we encounter is the f function. Then we just use the inverse of f to composite this function. So use x as the input, then we can get function value, and use this function as the input for the inverse function, the inverse of f of x, then we will get x back. But remember, all x will belong to B. So similarly, if we use f to composite f inverse x, or maybe if we also can just use this use y, then we can get it will be y for all y's belongs to R, or we say y belongs to the domain of F inverse. Actually, these two statements are the same, because for R, range would be the inverse of F's domain, right? As I told you, the role for range and domain will be changed when you just move from the original f of function to the inverse of f of function. Okay, this is node 1. Then node 2. The inverse function of f of x will be unique. 如果你一个函数有反函数呢，它一定是独一无二的。Actually, it's easy to prove it. For example, f1 of x I can prove it if f1, f2 are inverses of f of x. So you can see f1 of x, I can regard it as f1 of f composite f2 of x. Do you agree with that? Because if I say f2 is f's inverse, so when we just composite these two functions together, it will be identical. Did you remember that? Just find a corner, we have the result. Well, we just use the inverse function to composite the f of function, then you can get x back. So you can see x can be converted as this one. Right? Then we just continue. So we can just regard this as f1 of f of f2 of x. Right? So then you can see, you can regard this as an input. You can see this is the inverse composite f. Then we can get f2x back. So you can see finally, if we say f1, f2 are inverse of f of x, then through this proof, f1 of x must be f of x. 这个证明是要告诉大家，如果有反函数呢，反函数一定是唯一的，这个很重要哦。这等一下我们等一下，下礼拜我们会证明，你一旦找到一个反函数，它就是你唯一、独一无二的。为什么会来记这个定理？这个 note。那大家看一下，为什么这个证明？这看起来有点小小复杂，但仔细看一下好，如果我说我一个函数有两个反函数，那这个 f1 of x 呢，我做一个转换，这 x 是不是可以把它转成 f 去合成 f2x？ 大家同意吗？看一下右上角，反函数相合成的时候，你丢什么进去，它就跑出什么东西出来。所以我把这 x 呢，把它换成这样子。那换成这样子，相当于什么 ？f1 去合成了 f， 又合成了 f2， 对不对？好，这时候请大家怎么样？把这个看为一体的 哦，我现在手遮起这个看的一个东西，大家不妨把眼睛看在 F1 去合成了 F。你刚刚又说 F1 是反函数嘛，是 F 的反函数，所以当我 F1 去合成 F 的时候，你丢什么进去，就跑出什么东西出来。所以如果你从头看到尾 ，F1 of x 是成 F2 of x， 也就是说，当你说我有两个反函数的时候，事实上它们两个一定是同一个。假如它有反函数的话，哦。Okay. Then, before we go into the end of the class today, I'd like to give you this one, and then so that next time when I just talk to you about this part, it will not be the first time for you to know that. So this is a very important theorem, the derivative rule of inverse. If f of s has an interval I as the domain, and f prime x exists and is never 0, then we have a very important result. F inverse x is also differentiable at every point in I, and especially if f of a is equal to b, or we can say the inverse of f, b will be a, then we will have f inverse derivative b will be equal to 1 over f prime f inverse of b。 这个很重要，我用中文然后解释一下，因为我要让你们先带回去自己再先消化一下哦。如果我有函数 f 有它的反函数叫做 f inverse， 对不对？它也是个函数。如果 f 本身它是可微分的存在的哈，可微分存在，而且它的函数值不会等于0的话呢 ，f prime s 本身 f inverse 它本身也会是个可微分函数。然后呢，最重要的是什么？因为反函数它也是个函数啊，我会试图的去取出它的导函数，对不对？所以 f inverse 的 prime 是什么？注意哦，有 inverse 哦 ，f prime 你很清楚了，从第二章开始、第三章开始就学到 f 的 inverse 的 derivative， 现在是反函数的导函数，它等于什么呢？原来的函数取导数，放入反函数的值，再取导数。这两个导不一样哦。这个是导数，这个是导数。中文刚好了，好，我再讲一次，那这个回去要想一下，反函数的导数会是等于正函数原来的函数取的导数，好，这是原来函数，你看我这里面写 inverse， 这是原来函数去取的导数，放入反函数的值，再取上下颠倒的导数。那这个很重要的原因就是，未来的很多函数，当你要取它的反函数的导数的时候，你可以来自它正函数的原来的导数、原来的函数的导数去推算出来，包含lnx 的函数。好，那我们今天先到这里，这个先留给大家回去思考一下，礼拜一的时候我们再来讲哈。